We're here. We're almost done with the week. Okay. With that, actually, let's go ahead and look at agenda first, and then we'll do that. So today, we're going to be graphing with all key features when given factored form, vertex form, standard form. Now, I will emphasize and point this out. Which of these forms can you find well, what do I mean by key features? Let me ask that.
Things that are important.
So the ones that are important, which points are important, the features that are important for every parabola? Vertex, what else?
What?
Concavity. What are you saying?
I said the y-intercept.
Y-intercepts, what else?
X-intercept.
X-intercepts, there's one more that we always forget. Line of symmetry, right? So what we have done up to this point is we have actually found most of those features. Now, on your test on Monday, are you going to have to find all those features? No. No. Remember, each form has their own highlighted feature. What's highlighted in factored form that we can see right away without any extra work? X-intercepts and concavity. What can we see in vertex form right away without any extra work? Vertex and concavity and line of symmetry. Remember that line of symmetry has to go through the vertex. What can we see in standard form right away without any work, Peyton? Huh? Wait, you talking and not engaging? Uh-huh. So standard form, what can we see right away without any extra work? We gotta know this. So what is standard form? Girl, you got a test on this on Monday. We were working with just quadratics for a full week plus. No. You need to keep going. You need to do some check your understanding. Uh-huh. You know, you're supposed to know this, not just me. No! Oh, this is making me sad. Girl, ax squared plus bx plus, it's alphabetical. C, thank you. Woo! We got some studying to do. We got some studying we should have done before this point. But we got some studying to do. Come on, what can we see from this standard form? Like, first off, what can we see in every form?
Concavity and the y-intercept.
Concavity, what's telling us our concavity?
A.
A, right? Thank you. What's telling us our y-intercept? C, there we go. Alright, we got to know these forms. And good thing I'm doing some embedded review with this lesson. So remember, when I say key features, I mean all 5 features. But on your test, you will have to show me the highlighted features in each form, okay? Now, if you can show me all features, that's going to be stronger evidence, and that's what can push you into the exceeds portion of the proficiency scale. The target, though, is all the highlighted features, okay? Now, what I will point out is, factored form, this is the only one that you actually already know how to find all of the features with. Davian, why do you look at me like that? You're like, I don't know about that, Mr. Kenny. Is that what you're saying?
No.
It's a good thing you got a group to work with, right?
I didn't mean it.
Uh-huh, that's what I heard.
Heard?
Sorry, that's what I saw / heard. All right, so we're going to start with factored form because you actually do have all the resources to be successful in finding all the features with that factored form. And then we're going to use that work and those ideas to extend into vertex and standard, and that's going to be the introduction into our new unit. But we're going to start with Hero Friday, not Monday, but the agenda, right, the goal is how to find x-intercepts, roots, zeros in any form, which I just realized I never printed out the proficiency scale, so I'm going to get you to run and do that for me.
Sounds good, Mr.
In a second.
Mr. Kenny.
All right, so I'm going to turn off the lights. Mary, can you take us away, please?
Yes. Okay, so this is my mom. This is an old photo, but I just prefer this photo to like the more modern ones. Anyway, so this is my mom, and why she's so important to me is because she has really fostered a lot of my own passions. Like, she's the reason English is my big thing. She's the reason I love public speaking. I have her to thank for like everything. But anyway, so my parents got divorced in 2017, and it was I have a 15-year-old brother, but it was me, my mom, my brother, and my dad. And my dad had really severe drug problems, and when they got divorced, of course they were her full custody, but when they got divorced, my mom took over his role entirely. And me and my dad were really close, and we still are, like we still talk, but she's the reason like I have everything that I have. And it was really hard because my mom taught gifted in Tuscaloosa County for 25 years. And going off of just that salary with having 2 kids, I think 9 and 8 were our ages, was not easy whatsoever. And having to balance a job on top of that, already working with children while also raising 2 children with no husband or no one else to also have while doing that is really hard. And she did that for about 7 years, and we're still doing that. But my mom has given me everything that I could ask for. She has motivated me in every way possible. She has told me to just actively pursue everything. She is one of the most intelligent people I've ever met. When she went here and she attended here, she founded 20 clubs. She was involved in everything. She was a top senior. She has really influenced me to go after everything that I can. And with her teaching, I think that has also given me such an appreciation for teaching. And also not her, but just my grandmother also, my aunt. Almost every woman in my family taught or is teaching in Tuscaloosa County. She's still teaching. She's teaching Hillcrest Middle for math. But that has also influenced me not to teach at a high school level, but to go after teaching at a university for English, which is my big passion. She taught me how to read when I was about 4 or 5. So she is the reason behind everything. But I just want to share her because I think also single mothers deserve everything, and I think that it is so important to believe that even if you come from an environment where you have been through a lot, you can get after your academic goals, or not even academic, but just other pursuits. And I just want to share my mom. That's my girl.
Awesome, thank you. Whew. Now we have to do math, sorry. But, that's just where we are, that was awesome. So getting into the math, when we get started in a second, that's when I'll print out the proficiency scales for today. Oh, there's my remote. But this is what we're going to be moving into. So I just pulled the foundation and the target. Again, I'll be printing this out for you soon. But foundation, when I put foundation on this one, I went ahead and focused more on things that I know we should have studied heavily in Algebra 1. And so the foundation here is being able to use properties of equality and inverses to solve equations. We've already done that a little bit in this class with the last unit, and so we're going to continue working with that today. We're going to be looking at quadratic equations. I will point this out, I said a quadratic equation, that's a little bit different than a quadratic function. Does anyone know why I would use that language instead of a quadratic function? It's going to help us.
Because a function can be it can be a table.
So a function can be a table, a function can be an equation, it could also be a graph or even a verbal representation, right? A function can be anything that has blank and blank. They're being mapped to each other.
Input and output.
Say it again.
Input and output.
Inputs to outputs, right? A function maps inputs to outputs, and each input is mapped to one and only one output. Guys, remember, we got to know this for our test. That will be on our test. All the check your understandings we've done, that will be on our test. But a quadratic equation is this a function? Is that a function? It's an equation for sure, but is it a function? No. Why not? There's no what? There's no f of x, there's no y, there's no output here, right? There's a value for x, but there's no output. So these would be equations that we're trying to solve, find the solution to, and we're going to use some of these idea of properties of equality. I should have put inverses in here, I'll fix that. zero product property, etc. And so then we're going to move into this target section of being able to solve a quadratic equation when starting with factored form or vertex form. And that's one thing, but then we're also going to be solving quadratic equations with real solutions when given standard form. We legitimately are going to hit probably all of this today, not this piece, okay? Or the quadratic formula, or the fundamental, we might talk about fundamental theorem of algebra, but we definitely won't be doing the quadratic formula. And so we're actually going to do it with a little bit of a game, all right? And so here's how this game is going to work. You have your groups. Yeah? Groups? We're good? Yeah. We might actually do this just to give it a little bit more space, and since we're missing a few people, Sarah, why don't you join the kings, and Kennedy join the aces. Leah, can you go ahead and turn the TV on so that we can use this, okay? And now we have it balanced so that there's 3 in every group, except, sorry, Miles and Leah. Whoopsies. But we're close, all right? So here's how the game's going to work. I'm going to give you an equation, all right? And when I give you the equation for this function, I want you to work with your group to find every single feature of this function. So for example, I could give you a factored form like this, and I'm going to ask you to find every single feature of that parabola, identify those features, and then sketch a graph using those features. Make sense? Yeah? Hopefully. Any questions about that? Okay. Say again. So I'm going to give you an equation each time, and I'm going to ask you to identify every feature, not just the x-intercepts, not just the concavity, but also the vertex, also the line of symmetry, also the y-intercept. And so you're going to have to work with each other to bring all the ideas we have together. Now to make this a little bit of a game, I went and I bought some candy. Each round that we play, the group that finishes first will get to have one piece of candy. And so we're going to play multiple rounds of this to really get these ideas going. And after each round, we're going to debrief so that everyone has another chance to get that candy. Because I assume, like, we want candy, right?
Yeah.
Okay.
I actually do, Mr. Kenny.
I mean, you don't have to have candy. You can give it away to other people. I like candy, though, particularly chocolate, but that's just me. All right, so we're going to take a function like this. We're going to, my goal is each round 4 minutes. I think that's doable. We're going to have to work efficiently and work hard and talk with each other and make sure we're all in agreement. And whichever group can identify every feature first wins. Sound good? Okay. I'm trying to think. How many pieces of candy are in here? Well, I'm trying. I might change rules slightly. Don't tell me how many pieces of candy there are. Well, that's lame. I don't know. Never mind. I'll keep the rules as is. We'll try to play as many rounds as possible. So, we have our instructions, okay? So, I'm going to go ahead and let y'all start with this equation. Alright? So, identify all the features, get your sketch of the graphs up there, and let's get to it. Please leave that space open so that everyone can easily see that equation. Say again? Could have done to make our lives easier. But we got our graph here, we got everything else. So, remember, this was round 1. We're going to have another round of this in a second, okay? So I need y'all to engage. By the way, if you want to go ahead and grab your piece of candy, go for it. Unless you want to give it to a friend, and then you're a way nicer person than I am. Mr. Hobby and I might be munching on these later today.
No, of course not.
No, yeah, okay. All right, so let's look at this one. So, first things first. When I talk about this factored form right here, so remember guys, identify your factored form. I didn't see anybody do this, but what's my number 1 recommendation to help you get started? Write out the form, right? I saw one group get started with A, B, and C, but we don't have A, B, and C. We have A, R1, and R2. And so a lot of us, I think, very clearly recognize that this parabola is going to be concave up because A is positive. How do we get these x-intercepts? We need the what? We needed the opposites, right? Remember how it's x minus r1 and x minus r2? Now, I want to actually pause and I want to emphasize and remind you of a key idea. If I were to substitute 4 into this equation, what's the key idea that we're going to get here? What are we going to get? A 0. Remember, I talked about this a little bit yesterday. Our roots, our x-intercepts, are also connected to what key mathematical term? They're also called your roots or your x-intercepts are also called zeros. Because we need what output? 0, right? They're also called zeros. Hold on to that for this current unit we're starting. But again, like I'm creating a what right here? A 0, and using, this is the abbreviation for a really critical idea. It's on your proficiency scale. 0 product property. We needed to create a 0. And when I multiply by 0, I get an output of 0. Now, I think we're okay. We were okay on the roots, right? And identifying the x-intercepts. Does that sound fair? But here's what I want to remind you of to help us get going. Remember that once we graph our roots, where does that line of symmetry and that vertex have to be in respect to those roots? It has to be in the what? In the middle. Like, can we clearly see that x equals 1 right here is in the middle of 4 and negative 2? Now that's easy when I use 2 even roots or 2 odd roots. It's not always going to be that easy though. So how do we find that middle? I heard Kelly in your group, you talked about it. What did you end up realizing you can do to find that middle? Remember, we average, right? Mathematically, if I give you number 7, 15, 25, 23, Brianna, what are you going to do with those numbers to find the middle of those numbers? I'm going to average them, right? If I want the middle, and this is a sticking point for several of us, right? Drake, we got lost on that. We're going to use this in the middle. How are we going to find that h? We're going to average those roots. It's in the middle. What was that? 4 plus negative 2. Now the next thing was, hey guys, it's 4 plus negative 2, so it's a positive 2. 2 divided by 2 is 1. So what did this group do here to find their vertex, to find their k? What did they do? This is the work that they used. What did they do? They got h. By the way, notice I labeled it as h. That helps us not forget that that's the x value of the vertex, the input. What did they do? They substituted that 1 in, didn't they? Now, once you substitute 1 in here, you should not have an x here. What should you have? A 1. So 1 minus 4 is negative 3, 1 plus 2 is 3. And so 3 times negative 3 times 3 is, and they did get negative 27, but negative 27 right there. There's my vertex, h and k. Now, most of y'all, I appreciate this, but made your life way harder than you had to on the y-intercept. What did y'all convert this to? Standard form. Is that totally valid? Does standard form show us that y-intercept? 1,000 times yes, right? So y'all did a great job. I saw a lot of groups doing this. Notice x squared minus 4x plus 2x gave us minus 2x here, minus 8, and then they distributed their 3 to notice a y-intercept of negative 24. But really quickly, what does every y-intercept that has or will ever exist have in common? The x is 0. What's 3 times negative 4 times 2? What's 3 times negative 4? Negative 12. Negative 12 times 2? Every y-intercept that has and will ever exist has an x value of 0, an input of 0, right? So, is this a valid strategy? 1,000 times yes. Is it harder than it had to be? But does it work? Yeah. Well, you have to do this, by the way, for your test on Monday. Yes, right? Going from factored form to standard form is the only conversion you have to do for me on Monday. But that is something you're going to have to do. All right, what questions do you have about identifying all these features and then graphing them? We ready for round 2? We ready to challenge the 8s and do a little bit better than they did? All right, so here's our next one. All right, about to put it on the board. All right.
Now he said he did.
Super crazy, I know. All right, here's our new function. Please note, negative 1/2 times 3x minus 6 times x plus 6. Negative 1/2 times 3x minus 6 times x plus 6. Juicy. I know, right? Yeah. First things first. We have this function, negative 1/2 times 3x minus 6 times x plus 6. Okay? First things first, I think everyone did a great job of identifying that my concavity was what? Down. A couple of students did a great job of recognizing right away, is this the traditional factored form that we've been working with? I thought I said get closer, like y'all like all the way against that back wall. I need y'all up and in this space, standing, engaged, Davian, Peyton. Come on, Mary, Kennedy, Leah, thank you, all this way, okay? Come on, come on, come on. All right. When we look at this, is that traditional factored form? No. And so this is why I asked you, and I pointed this out to several groups, what's another word for our x-intercepts or our roots? Zeros. They're called zeros. Because what do we want to create? A zero. And so some of us naturally figured out what x value made that a 0. But I need y'all to hear me clearly on this, because I'm about to make your life easier if you pay attention to this, because this is a third of what our next unit is on. What are we trying to make? So what is my output? And so what has to be true if I have a product of 0? One of two things has to be true. Either, come on, I'm waiting on y'all. Bless you. Either x plus 6 equals 0, or 3x minus 6 equals, what property are we using there? Remember, that's called that zero product property. I'm going to abbreviate it this way, but say it the whole way. Zero product property. The only way to get a product of 0 is if we're multiplying by a, so at least one of those factors is equal to what? 0. At least one of my factors is equal to 0. And so remember, we actually talked about this. I told you the very first time we looked at the factored form, I showed you this to explain why it has to be the opposite, right? I had to subtract 6. So what does x equal? And a whole bunch of us thought that this was a 6 here, didn't we? That is the opposite. But because there's that 3x there, what does x actually have to be? 2. Notice, if I divide by 3, what's a third of 6? 2. It's actually 2. Guys, when you have that factored form equal to 0, what are you going to use to find your roots? Factored form equal to 0. 0 product property. You got that factored form equal to 0, use your 0 product property. We good with that? Okay? From there, and by the way, I'm going to write all these notes on, I have these things called white books. I'm going to write all these notes while y'all are working on the next part so that y'all can take a picture of it as you're leaving the room, because I want you to have some of these key ideas, and I want y'all practicing rather than working on notes today. We'll work on that more on Monday. All right, from there though, we got our roots. What are your questions about those roots, about those zeros? Do not forget, we need those factors to become what? Zeros. They gotta become a zero. And so, Landon is way too tall for me, so I'm not actually gonna mark that one. I'm gonna just mark it here. Notice my -6 and my 2. All right? -6 and 2. Now, a couple of groups took a few different routes at this point. This group over here, they actually converted their factored form into what? Standard form. Then they distributed that -1/2. They just had one small hiccup. Pay attention to your positives and negatives, right, Landon? Yep. But notice, how did they calculate H? What did they do? -b divided by 2a. Is that valid to do? If you've got your standard form, can you find H that way? 100%. Can that help you get to vertex form on the test on Monday if you want to go that route? 100%, right? So from there, and that's actually might help you in the next problem we do, but at the same time, this is what I would do. What did this group do to find H? We averaged our roots, our zeros. -6 plus 2 is -4. -4 divided by 2 is? -2. Ooh, so I just noticed y'all, what went wrong? When y'all got your standard form, I think that's the problem. Y'all forgot to distribute that -1/2 to the...
Yeah, the negative.
Oh, when they...
Yeah.
So, the group of kings, I want y'all to look. -1/2 times -6 is a positive 3x. That's part of the problem y'all ran into. Be careful with your positives and negatives. Okay? Next, though, and I need y'all to remember this. I need y'all to hold on to this because this is going to make your life easy. F of H, what does that equal? K. If my input is H, my output is K. Guys, I am only going to use an equation I actually have. So I could have used this factored form, or if I calculated my standard form, I could have used that standard form. But guys, you can't use the vertex form here. You don't have K. You're trying to find what? K. So F of -2 is -1/2 times 3 times -2 minus 6 times -2 plus 6. I think they did that somewhere.
It's right there. Bottom.
There we go, right? And so they did that work right here. They substituted their -2 in. If you want K, substitute your H in, get your K out. Good with that? We good? Miles, you less frustrated? You learning from it? You did it that way eventually? Man, if you hadn't sat down, you could have been there, bro. Guys, substitute H in, get K out. So F of -2 was equal to -1/2 times -12 times 4. -12 divided by -2 is 6. 6 times 4 is 24. So an input of -2 had an output of 24. We had that line of symmetry, right, at x equals -2. Make sure, because I don't think I held this group to this. Oh yeah, they did. Line of symmetry, x equals -2. And so we have vertex, we have x-intercepts, we have line of symmetry. All we needed now was my y-intercept. Just because I know I asked Drake this last time and I want to make sure we're tracking, every y-intercept, what do we know about it? That x is equal to 0. So what did they do with that 0? They substituted it in. Could we have substituted it in for the standard form over there? Could we substitute 0 in for the standard form? Yeah. We can also just see it as C. But at the same time, you already had the factored form. So did I need to get that standard form? Guys, if we're looking for a y-intercept, what is x? It's 0. going to matter for this next one. So please keep that in mind. They just substituted their 0 in. And then they got out 18. These are my features. What are your questions before we move to the next one?
I have a question, Mr. Kenny.
Go for it, Mr. Hobby.
Our original function looks so close to factored form. Is there a way we could have made it factored form?
In this one, yes. Technically in all of them, yes. Do I recommend it? Not necessarily. The reason why you could do it is, I could have taken that 3, factored that 3 out. Notice, what do 3 and -6 have in common? They have a factor of 3. So if I factor my 3 out, so thank you for that question, Mr. Hobby, I'm going to do 3 times -1/2, which is -3/2, and then I factored this 3 out, so I'm left with x minus 2. What were my roots again? 2 and -6? So you could have gone it that way, but zero product property is your best friend. That's the way I would recommend doing it. All right, y'all ready for your next problem? We're going to extend this a little bit. We're no longer going to do factored form, which means you're going to have to take the information you have to help you find a couple of different features this time around. Okay. Your f of x is 2 times x plus 2 squared minus 8. 2 times x plus 2 squared minus 8. Same directions, all features, and go. Dang, why are you trying to break my calculators, bro? This for tanks back there. This up here, and I want to talk about some key ideas I'm going to pull from around the room. So again, moving to the center, I'm going to write on here and around here so that you can take a picture of these notes. I'll expand a little bit past this. But I'm going to keep these notes up around the room as a reference for later this year. So first off, our function was equal to 2 times x plus 2 squared plus or minus 8. All right? And so when we look at that, what was the first thing we noted about this equation? I heard everyone talking about this, which was awesome. Okay. Though it's what? We noticed the vertex, because what form is this? Vertex form. And so what was my vertex here?
-2, -8.
Okay. Why was it -2? I see x plus 2 there.
Opposite.
We need those opposites, right? When it's x minus h, right? We need that opposite. Whenever it's the x minus r1, x minus r2, I need the opposite. And so again, don't forget, if I substitute -2 in, what's -2 plus 2? 0. Remember, we're trying to create that 0 even in that vertex form. And so -2 comma -8. Nice. All right, well, any other features we know right away from this vertex form?
The concave up.
Concave up. How do we know concave up?
Because A is equal to 2.
A is positive. A is equal to 2. So concave up. Sweet. Anything else we know? Super close. Be careful with the way you say it. Mathematically, this is important.
X equals -2.
So remember, it's a line, right? The whole point is that every x value is -2. -2 is just a number. I need the line where every x is -2, right? So let's go ahead and start sketching this. I think I can go by ones this time. So I'm just going to count it by ones. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So -2, -8 is right here. And remember, what I need is every point that has an x of -2. That's this point, this point, this point. See how all these points have an x of -2, don't they? Okay. So I'm not going to put points here because it's just the line of symmetry. It's to help me. But that's why I put a dashed line. Every point on this line has an x of -2. So I have to say x equals -2. If I don't say x equals -2, I don't have a line. Okay. All right, we got the easy stuff. What's the next easier one? Because which one were we all struggling with? The x-intercepts, the roots, those zeros. And so some of us found it in a very ingenious way. I messed up a little bit with this equation. I should have changed a few things. But how do I find my y-intercept then?
Turn it to standard form? Or well, I mean,
You can. A lot of us changed it to standard form, didn't we?
plug.
I would say, if we want a y-intercept, what do we know about every y-intercept that has and will ever exist, Shadidra? Huh? What do we know about every y-intercept that has and will ever exist?
Zero.
What's 0? We need to be careful because the x can be 0, the y can be 0, but when it's a y-intercept, I need a y and the x is 0, okay? So, I'm going to substitute that 0 in. And so when I do that there, how'd you get 0 minus x minus, was it x minus 2? No. Gotta be careful. Be careful. Okay, so 0 plus 2, what is 0 plus 2? 2, woo, 2 squared. 4, 2 times 4. 8 minus 8.
0.
And so the input of 0 has an output of 0, which is how some groups found the other x-intercept. Did not intend for it to work out that way. It just happened. But here's what I now need us to pay attention to and what I want us to see. X-intercepts. And this is what we need to take note of. What do we know about every x-intercept that's ever existed?
Y is 0.
The y is 0. The output is 0. So not x. That's what we're trying to find. The output is 0. So this output becomes 0. What can I do now? What have you done in the past to solve an equation like this? And let me also say this first. A lot of students want to go to standard form here. You can. Standard form is actually the hardest form to solve for your x-intercepts. I am always either going to do factored form, because what can I do in factored form? What key property? Zero product property. That one's nice and easy, right? Or I'm going to go to vertex form, because what can I do with this equation?
Distribute.
So remember, if I distribute, that's going to help me go to standard form. I don't want standard form. That's the last form I want. Okay, I'm going to pull on this idea, solve it. What do you mean by solve it? There's two things that we do when solving. Simplify, and then we use, starts with an I, inverses. Guys, when you have an equation and the variable only shows up one time, and it's like this, simplify, which I can't, that's as simple as it gets, and then I use inverses. Now the tricky part here for a lot of students is knowing what order to do my inverses in. I'm not going to distribute that 2. I'm not going to square this. I'm just going to use inverses here. First off, I want to make sure it's clear why we cannot do 2. What's the first thing that's happening to x? What's the order of operations? What's first? Parentheses. So what's happening to x first? Adding by 2. What happens after parentheses? So it's x plus 2 then squared. What's happening to x plus 2 squared? Multiplied by 2. And then what's happening to 2 times x plus 2 squared? Minus 8. That's the order of how these things are happening. So does anyone know what inverse I should use first? Let me give you a hint. What was the last thing that was in that order? Well, the last thing there was the minus 8. So you know what's going to be easiest to do here? Well, take care of the subtraction, so what's negative 8 plus 8?
0.
Whatever I do to one side of the equation, I have to do to the other. What's that called again? It's on your proficiency scale. It's another property. We got an equal sign in there.
Inverse order operations.
So we are using the inverse order of operate or the inverse operations, but what is it? Whatever I do to one side of the equation, I have to do to the other. I think you said it. Properties of what?
Equality.
Equality. Guys, the idea is, so I need to point this out. This equation, does this look exactly like what we started with? It looks very similar, but you said somewhat. So does it look exactly like it? But is it telling the same story?
Yes.
So this original equation and this Brown equation are what? Say it again. Equivalent. I'm sorry, Miles, I didn't hear you say it. Listen, guys, they're equivalent. They may look different, but they are telling the same story because we used a property of equality. Next. All right. Now, again, what's happening to x first? Adding by 2. What's happening to x plus 2? It's being squared. What's happening to x plus 2 squared? Multiplying by 2, right? So what do I need to do to undo that? I need to divide by 2, right? The last thing being done is the first one I'm going to undo, so I'm actually going to scooch that over, just so I can use my reciprocal. Again, can you just show division? Sure. I like that reciprocal. It's known as the inverse. It's literally the inverse. So what's half of 8?
4.
Now this is the part I need you to pay attention to most closely. What's the inverse I should use now? Square root. The inverse of a square is a square root. It cancels out that exponent. It actually makes that exponent a... When we're using inverses, we're trying to either create a 0 or create a 1. And that just made my exponent a 1. So what's the square root? Well, so on the right-hand side, I'm left with x plus 2. What's on the left-hand side?
2.
But how many roots am I supposed to have? Aren't I supposed to have 2 roots? So is it just 2? Okay, let me ask you this question.
2 and negative 2.
I was going to say, what squared is equal to 4? 2 squared is definitely equal to 4, right? But isn't negative 2 squared also equal to 4? In Algebra 1, didn't you have to get both a positive and a negative when you took that square root? The same thing is true here. 2 is equal to x plus 2 and negative 2 is equal to x plus 2. So, remember that you need 2. So we need a positive and a negative. If you ever see a positive above a negative like that, you can either read that as a positive and a negative or plus minus. It depends on the context. So like here, that's positive negative 2. That's 3 plus or minus 2. Okay? So it's just the context matters. But what am I now going to do to solve these equations? Guys, these are simple equations. Now, come on. Thank you. Minus 2. What's negative 2 minus 2? Negative 4. What's 2 minus 2? So I get x equals negative 4 and x equals 0. And that was when my output was 0. And so does that match these
Teachers, please
x-intercepts?
pardon this interruption. I need a couple different groups to meet me in the theater during enrichment. So if you are on one of the Patriot game teams,
There's my
I announced that
parabola.
yesterday. If you don't know who you are, you might ask
If
around.
you have
Hopefully
factor
you know who you
form,
are.
what
Also,
do you
if
want to
signed
use?
up to play in the
Zero
college football
property.
tournament, or
If you have
the video
vertex
tournament,
form, what do you want to
you know,
use?
I'm in it too. I'm excited. Please join me in
What
the
do we use?
theater during enrichment. Those two groups.
Huh?
Video gamers for football.
So properties of equality and what? And inverses. So if we're trying to find zeros in that vertex form, we're going to use properties of equality and inverses. If we're trying to find zeros in factored form, what are we going to use? Zero product property. So keep that in mind. Please go ahead and take a picture of these notes. I know there's a whole lot going on here. By the way, I did not get to updating that check your understanding. Oh, sorry. Everyone, all the 3 groups that I identified that you get candy, you each get 1 piece or 2 pieces of candy right now. Everybody can get 1 piece of candy right now. Okay, so the three groups, I think it was the 9s, the 8s, and the kings. You can grab 2. Everyone else, you can grab 1 piece of candy at this point. Hey, guys, by the way, what do we have on Monday? Yes. Make sure we are studying. I will update a video on YouTube that has the last set of check your understanding questions worked through.